Welcome everyone for the final talk today. So imagine you have started a new application, like one of these awesome voting apps where you can vote for tabs versus spaces, CloudFormation versus Terraform or so. And you also have created a Docker image and everything works quite nice locally. And now you find a way to deploy to production. And of course you do infrastructure as code, right? You do start with CloudFormation and with the stack template and what resources do you actually need? I know there's an ECS service, I also need a task definition. Let me copy that for my last project. And then how does it work with scaling again? Because I want to scale automatically and let's have a look on the AWS resources. Let's add that as well. And I forgot the monitoring. I have to set it up. So which metric should I check again? Let's see. Maybe the guys from Cloud now have a good example or so where I can look up and add that as well. And then I of course also need a load balancer, right? People have to access my service and IAM and so on. And at the end, for your simple application, you end up with the infrastructure that contains a couple of hundreds of lines, 700, 800 lines or so on, of YAML code. Does it sound familiar to you, maybe? Then just took ECS as the example. You can do that with all other resources, RDS, Lambda, EC2 setups, and so on. It always ends up, at least for me, like that. You can, yeah. It helps also a bit. So maybe a short introduction about me. My name is Philipp Garbe. I'm working in Munich at Scout24 as lead platform engineer. And we have seen such problems as well in our company. And where that actually started was that we had, like a colleague of me had an idea how to do that also with splitting up in smaller parts and maybe reuse them. And so on, and we also started thinking about making like a product, a tool out of that, where we then also came in contact with the CDK team, stopped doing so far, and we're waiting now for AWS to release a stable version on CDK. But in this talk now, I want to start with infrastructure as code. Then what are the pains or what are the limits of CloudFormation right now at the moment? And what is then exactly the CDK? I'm not sure if everyone have heard about the CDK so far, and how can it help you to boost your infrastructure as I promised? Maybe a short question. Who's doing infrastructure as code? And who's using CloudFormation? Okay. Why infrastructure as code? Why is it? What is it, and why is it so important? I took a definition from Keith Morris, who also wrote a book about that, where he said the enabling idea of infrastructure as code is that the systems and devices which are used to run software can be treated as if they themselves are software. So if you think about that, maybe your EC2 instance or load balancer, think about it, it's just software. You can create a new instance, can remove it, you can change properties and so on. It's not, just virtual. And why is that so important? Why is that so interesting? I think one of the key features here is that you can automate all the things. So you don't have to click around on the UI and maybe then also forget what you clicked around. You just define what you want. And then let's, in that case, CloudFormation, as an example, do what you want. That just needs to then fulfill your wish, actually. And it's repeatable. So you can use the same template again and again and create stacks and stacks and stacks and so on. They all look the same. They create the same resources. I can, even if something goes wrong, so I can delete it and recreate it. I get the same things again. And what I especially like is that you can use these definitions. It's normally like a text file, YAML file, or whatever, JSON, you can put that also in source control. You can put that to your application code or next to your application code, and you can use all the benefits that you have from version control, like blame or history, or have a diff or so, what happened exactly, and can look things up. There are actually two ways how you can do that. There's a declarative way and an imperative. So on the declarative part, it's more about the what. It's easy to understand, so the barrier to use that is very low. If you think about such a YAML file or so, the syntax is normally quite simple, straightforward. You don't need much knowledge in advance to just use that, such things. But it had also some limitations. So you have not the full control of it. So like further constructs like loops or so on are not easy or are almost impossible to do within the YAML syntax. Or think about inheritance and such features. It's just not possible. So you have then on the other side also the imperative way to do that. So it's more about saying how to do that, how to set it up. And that needs, of course, the barrier is a bit higher. So you have to know the tools or the language that you're using in that case when you want to program such things. So the initial effort is a bit higher, especially if you're not used to that language. But on the other side, it gives you more flexibility. Like I said, you can use inheritance and such techniques that you are used from your normal application development. You can then also use for your infrastructure. So when you look at CloudFormation, there are both ways are also supported there. So you have when you think about CloudFormation, normally you think about these YAML or JSON files that you also find in the docs and so on. And this is just a declarative way how to do that. And it provides already some options with the transformation to make things a bit easier. Like SAM is a good example for the serverless application model. I think it's the abbreviation, where we have a shorthand syntax how to define this all the resources, especially that you need within serverless setup, which then is transformed into a larger CloudFormation template. And you can also have your own transformation where you can basically do the same. And yeah, like there are also then these advanced transformation where you can have also a Lambda in behind where you have an input with 2 or 3 lines or so, and then you can expand it and make it even bigger and bigger. On the imperative side, there are already some existing ones like Troposphere, Sparkle Formation, which is the implementation Ruby, and CodeFormation, which is written in Golang. Troposphere is in Python. And in that part also comes the CDK. But the common pattern here with all these tools at the end, it always generates a YAML file, which is then sent to the CloudFormation API. So everything here happens actually before it is sent to the CloudFormation backend and then executed there. Which brings us also then to the limits of CloudFormation, or these pangs. There are a lot of good things with CloudFormation. It actually normally does what it should do. And it helps a lot in regards of infrastructure of code. But let's have a look on some of these challenges, which are categorized in like time, security, and trust. Like the example in the beginning, we've seen it can become complex very, very easy. You just want to have, like a single job or a single application that you want to deploy, but you need not only one resource, you need many resources. They needs to be combined, they have references for each other. And all that stuff that you write here, it's actually code, even if it is in YAML, and it needs to be maintained. You have to care about that. You have to maybe update it and so on. And refactoring here on that level is way more complex and sometimes even impossible compared to another programming language. One thing that I've seen also in our company a lot, and I also when I talked with other engineers, is when they start something starting with CloudFormation, they often do a copy and paste. There's either they copy just a snippet from a project or what they Googled, or they copy the whole template and then adjust it to their needs, what they need for their new project. And yeah, is copy paste really smart? And maybe think copy paste is quite fast actually, but I think it isn't, because it costs you time. You have to find that where you want to copy from. You have to review it, and then maybe also adopt it to your actual needs. And then there's also trust when you think about these snippets when you copy from. Can I trust that person where I copy from? Maybe I don't know him, or even what I have seen is that people have some different kind or different levels of trust. So they maybe trust their team more than maybe other teams in the same company, and there's almost no trust if you look up some stuff on Google and StackOverflow, which means then you have to also go through it and check if it's doing something bad or so. And it's not about so much about malicious code, although that can happen if you think about if you add some Lambda layers or some Lambda code and copy paste into your templates, and we use the same Lambda code which is then executed in your account. And also, one thing that you often don't know is it really complete, that snippet? Is it like if you think about CloudWatch alarms, they can be really tricky. It's likely that you forget maybe something, so if you copy that, you don't know if it's a good template or not. And what about updates? If you find maybe a critical problem with the IAM settings or so on, and you copied that, how can you then think about that the one where we copied from does not know about your changes? Maybe you let him know, but if you think further, maybe some people or some other people also copied from that. They don't know that he applied an update. So there is no standard way or an easy way how to apply updates and roll it out to everyone who is using that. And we have also seen, or what we want to improve in our company is that we align the people on best practices. You can tell a lot of best practices, but it's not that good as when you have some written code which is following already the best practices. So people are automatically using that. And there are a lot of learnings if you put some services on AWS in production. That's some tweaks which you maybe find out later on and so on. And not every team should learn or do the same mistakes again and again. You can learn from each other. And then there is no easy way how to share that easily. And if you look, for example, at the AWS docs, this is just a reference what you can use, but it doesn't tell you the best practices. If you look again at the CloudWatch alarms, it tells you what options you have for each field, but which alarms or which metrics should really be watched for an RDS database or for a Lambda or whatever. It doesn't tell you. So what is the CDK then? CDK stands for Cloud Development Kit. It's an imperative approach how to write the infrastructure as code, and it supports already a couple of languages out of the box. So you have JavaScript, TypeScript, Java, .NET, and also Python, and I think Golang is on the in the queue. It's currently in beta. It's public available on GitHub, so you can already use it, try it out. But be aware there are many releases. I think once a week or so they publish something new. But there also there's a lot of stuff still ongoing, so you have also regular breaking changes in that. I think you can use it because at the end it just creates CloudFormation, a YAML file. So it's also, in my opinion, not so problem to put it in production. But I think it's some effort to maintain that with the breaking changes at that current state. Yeah, three things in the CDK, three different types where we have to deal with. One is the app. It's an executable program. It's then used to render and actually also deploy your CloudFormation template. Normally, you're not seeing that much because it's auto-generated in just a few lines, so it's not that important. More important is then the stacks. You can have an app multiple stacks, which then also, this is the deployable unit, which then also create the stack in CloudFormation itself. There's a one-to-one mapping, and it has some environment, so it knows about the region which account it should go. And the interesting part here comes then with the constructs. So each stack can contain one or more constructs, and constructs can also contain other constructs. So you can build on top of them. You can form this hierarchical tree structure. And a construct is like a representation of an AWS resources. And if you look about what's happened, so you define your app, your stacks, your constructs, and then you use the CDK CLI, which acts like a compiler. With the synthesize command, you can generate such a CloudFormation template, but you can also deploy it directly to CloudFormation. So when you work with it, at some point, the template is not that important anymore. You're not looking at the YAML code anymore. It becomes like an assembly language. It's there, you can look up things, but you're not using it anymore. But you can deploy them directly from the CDK to the CloudFormation. And with these constructs, there are three levels of construct that you have. And the level one is like a one-to-one mapping of the existing CloudFormation resources. The same one that you write in your YAML code on the resources, or each type has also a level one construct, and it's auto-generated based on the CloudFormation specification. The level two construct is done on a service level, like ECS, Lambda, and so on. And it combines already, most of the time, one or more of these other level one constructs. And they are handwritten, mostly by AWS, but also partially from the community. They are opinionated, but following these well-architected frameworks that AWS also have. And then level three, here's the stuff that you can write. You can build your stuff on top of the other ones, and you can, for example, create production-ready services. For example, you can create a Lambda with all typical alarms that you need in a production environment, like execution errors or so on, that you normally want to watch. So you don't have to do that again and again. You just define a construct containing the Lambda function, containing also the useful alarms, and wrap that as a level 3 construct. You can also use that, bring that a level up, and build reusable solutions. Like there's an example with a tweet queue. It's a construct library which contains, or which allows you to get the feed from Twitter. So the only parameter is like a Twitter API key and then a keyword what you look for, and then it automatically queries Twitter and sends the result in SNS queue. It's more high level, but you can also write them so that you can reuse them easily. Or there's a table view for DynamoDB, which actually deploys a whole more or less a whole application to see the content of your DynamoDB. But let's have a look on that, how it looks like, and I prepared a video because we will create some resources which takes some time and to speed up things. I have that video here. I hope that works. So you can do now here a CDK init, and you can also define the language where you want to have your template, or which template you want to use. In that case, it's TypeScript. Recently, Python has been announced as one. It came out of the beta to be supported, and it creates already some files. And if you want, so if you use TypeScript, you can run this watcher, which automatically compiles the TypeScript code into JavaScript code, so that you don't have to do that manually. But when you save things, will automatically generate it. There are also, I think, plugins on VS Code to do that automatically. Then installed some dependencies that we need. So they are separated into the different npm packages so that you can install. And here we have already some stack. And you can call the CDK diff command, which generates then all the resources that it will create, update, or delete. And you can see that on the top, it's just one line where we create a whole VPC. And we can also synthesize that. That's the whole YAML code that will be generated out of that single line. And the good thing is, all the resources here have very sane defaults. So you can override a lot of things, but the defaults are already very good. And of course, you can also directly deploy that. So it's synthesized and then sent to CloudFormation. It change that. You see then also, which is very nice, I think, you see the output, what is happening in CloudFormation itself. So it creates then all the resources. And normally, creating such a VPC takes a couple of minutes. But it should be done, And then, create an ECS cluster. That's another line, which references the VPC. And in addition, we create also a Fargate service. And there's already, you see this opinionated construct, load balanced Fargate service. So it creates already, it creates not only the Fargate service itself, but also load balancing before. And if you want to deploy that, it's quite interesting. It stops and asks you if you to review these changes, because with that changes, we are also doing some security group changes and IAM changes. So we have not written anything about security groups or IAM, but these things are generated for us. They are implemented in these constructs already. And if you look at these, they follow also the least privilege principle. So it's only allowing the things that actually needed. And it knows them because we have this connection between inside the load balance Fargate service, we have the connection between the load balancer and also the Fargate service. After we have reviewed it, we can deploy it, and it shows up. What we also said, we want maybe some scaling. So you can extend that. There are some preconfined scaling options already, where it makes it very easy to scale based on the CPU utilization. And of course, we need some alarm. And also here we can use the metrics. There is some convention like .metric gives you all relevant metric options of that construct. It makes it easy to use it, and you don't have to fall into the pitfall that maybe you have a typo or so. This is automatically checked by the compiler. So you get the right name of that CloudWatch alarm namespace, I think it's called, and so on. Also here we can then deploy it again. And to prove it, it's like just a normal CloudFormation stack. So here you see actually no difference where it comes from. We get automatically the output of the load balancer. Here is big list of all the resources that have been created with these few lines. Again, that's then you can see also the cluster has been created. We see the service for Fargate with the load balancer attached. We have already some tasks running here, and we see also the auto scaling has been created for us. And we can also change that to use not a public image from Docker Hub, where you can also use an ECR repository or create one and use then an image from the ECR. And if we want to deploy that again, and it asks us about the changed permissions. So we see we allow now this ECS to have pull access to that ECR repository that we created. And if you know how to do that with the pull access, it's not only one action, so you have to, I think, set up four or five actions, and you have to know them. And that's how it works with CDK. And I think that is already a boost, because it saves you already a lot of time. But especially these level 2 constructs. So there are a lot of standard use cases which are already done and implemented. I had, for example, I wanted to create my own construct with the Lambda, which also creates a CloudWatch logs group with a retention time, because that is not done automatically. So Lambda logs, and then it keeps the logs forever. And if you want to have a retention time, you have to create a CloudWatch log group before the Lambda is being at least executed with the same name as the Lambda. And then you can also define the retention time. So I wanted to write that construct, but in the meantime, it was implemented as a layer 2 construct as well. So I could throw away my code again. So there are a lot of these things already included. It has already very good defaults, so you don't have to write so much, or you can rely on that. They are they save you actually. And we did not write any IAM permissions so far for that. So there are still cases where you have to do that, where I cannot get it out of the context, especially when you have, for example, a Lambda and want to access a DynamoDB in your Lambda. It doesn't know actually about that. But a lot of cases, it's already included, and it will do the heavy lifting for you. And then I think where real boost will come, it's not yet there, will then be with the layer or level 3 constructs, that you can build your own reusable construct and share them as CDK libraries with others. So it uses the existing package manager, so you don't have to learn anything new. A lot of things, so especially CDK itself is written in TypeScript, and they use the NPM mainly. So you can also do the same and publish with, and use the existing infrastructure of these package managers and share that with everyone. But also you can do that also within your company and keep, if you have a private package repository, it can be also done. The investments are normally already done, so you can just reuse that. And then you can benefit inside your applications from these shared libraries then. So talked a bit about time, security, and trust, and I think, or I hope that it could show that it helps a lot in these areas, because you know who published things. It's like any other library. You have to build up some level of trust. There are downsides as well, but I think it's at least on that part for infrastructure, it's a level up or a step forward. And also, if you don't trust external ones, at least you can build your own libraries and share them internally. It saves you also, I think, a lot of time, because you don't have to reinvent the wheel again and again and again. You can benefit from these level 2 constructs a lot and have them and normally have always repeating use cases in a company, maybe 3, 4, 5 different ones, but they're repeating time and again and again, and setting up such infrastructure with just a few lines saves you, I think, a lot of time. Also, you don't have to try them out. Like, at least for me, it's like if you write CloudFormation, you type and then you deploy it, and then something fails because you made some typo or some other stuff is missing or so. This is not the case with the CDK, because the compiler checks already a lot of things. And you can also then write tests for that. Didn't cover that so far, but also the CDK team has built some internal tools that helps a lot to write such unit tests, to where you then also have the intent, or you can make visible the intent why a certain flag needs to be there, or why a certain resource needs to be there. I think that's a big benefit of these tests. And in regards of security, I think it's a very, very good point to use existing package managers, because what they can do very well is doing updates. And now, so dependency managers are rising up and popping up. So they are also helping you with managing your dependencies, sending you pull requests, or maybe also automatically merge things in your repository, so you don't have to care about that anymore. And if you have some fixes also, you can then easier distribute them through the package manager, and don't have to maybe do a GitHub search or whatever, or ping some people. If you have copied from that template, please see my changes here. Yeah, it's an imperative way to use CloudFormation. The interesting part is you can also use it in your favorite programming language. What they do is they write the CDK stuff itself in TypeScript, but at the end they compile it in all these different languages. So these packages are published as NPM packages I think it's Python modules, as .NET assemblies, or as NuGet packages actually in .NET, and also as Maven packages. They vote, it's another internal tool that they use, it's also open source, it's JSIA, which use TypeScript and compiles in these different languages. Yeah, I said already it can save some time, and it also makes it easier then to align on these best practices, as you can write these best practices as code, and not maybe just some saying, documentation, or some wisdom what you have in your company. Yeah, I already mentioned there are some breaking changes, but it should be, I think, they have not announced on version 1, but I hope that it comes very soon. Also, the coverage of these level 2 constructs is not for every AWS service there at the moment. They focus, I think, on the most important ones, but maybe some exotic ones also will just have these layer 1 constructs, which is not worse than pure CloudFormation, because it's the same, actually. You still have the same CloudFormation limits, like 200 resources per stack, which is maybe not that obvious anymore. If you write that in a YAML file, at some point you will see, okay, it's a long file. Makes it maybe obvious that you will maybe run in some limit, but that couple of lines of code, maybe it's not that obvious anymore. So maybe, something will happen there as well. And with the language support, I said already that TypeScript can be compiled in different languages, but to do that by yourself, and if you also want to publish packages or these libraries, and maybe want to that everyone can benefit from that, or often you have also distributed or the heterogeneous setup in your company, where people have using different languages, then you maybe also want to do that. In that case, you have to use TypeScript when you want to program these CDK libraries. Yeah, I mentioned a bit unit testing and that stuff. There's a nice workshop which you can also do, so step by step, this is cdkworkshop.com, which also explains a lot of things and shows you how you create such an application, but also how to create such a library, and we use that. The sources itself are available on GitHub. There are also issues there, you can comment on them, you can get in touch with them. They are really nice guys. They are also there on GitHub, where you can ask questions how to do that, because what is lacking a bit is documentation. So there is documentation, but if you want to go deeper or want to use, fulfill some specific use cases or so, maybe you need a bit more, which is not in the documentation. So what I normally do is I look in the sources, or actually in the test, because then you see how stuff is used, actually. Okay. That's it so far. If there are any questions, I'm here. I hope there's some beer as well.